Good morning, my lovely kiddos and my future mathematicians. Today, we are going over day 2 of our study guide. So, yesterday we talked all about the Pythagorean theorem. Remember that the Pythagorean theorem is a squared plus b squared is equal to c squared. We learned that in 9.1b, and in 9.1c, we learned an expansion to the Pythagorean theorem. Okay, and that tells us that if a squared plus b squared is equal to c squared, then we have a right triangle, which makes sense because our Pythagorean theorem works with right triangles. But the expansion comes with a squared plus b squared is greater than c squared. What happens when the sum of our squared legs is greater than our hypotenuse? Then we know that we have an acute triangle. And the third one, which we probably could guess, is that when a squared plus b squared is less than c squared, our hypotenuse squared is much bigger than our sum of the squared sides, then we have an obtuse triangle here. So let's go ahead and do 2 examples of that real quick. All right, so here we have a triangle with the lengths 2, 5, and 6 on our sides. All right, the hardest part of these problems is going to be to determine which go in for A, which goes in for B, and which goes in for C. Okay, well, remember that C is our hypotenuse, or our longest side. Okay, so we can always look for our longest side, in this case 6, and plug it in for C, and let the other 2 go in for A and B. It does not matter which one. Okay, so I'm going to put 6 in place for C. I'm actually going to put a box here instead of an equal sign because we don't know if it is equal, greater than, or less than. We're going to figure that out. And then the 2 in for A and the 5 in for B. Again, if we had switched those are totally fine. Okay, so 2 times 2, or 2 squared, gives us 4. And 5 times 5, or 5 squared, gives us 25. And 6 times 6, or 6 squared, gives us 36. 4 plus 25 gives us 29, and 29 is less than 36. So this is an obtuse triangle. And we can see that this angle here looks like it is greater than 90 degrees, so it would make sense that it is an obtuse triangle. The second kind of question that we could run into with this is, instead of having a picture, we just have numbers, 6, 8, and 10. Okay, these represent our side lengths, and we still want to find out if we have a right, acute, or obtuse triangle. So again, the hardest part of these is to determine what goes in for A, what goes in for B, and what goes in for C. We can always figure out what goes in for C by looking for our longest side, that hypotenuse. We can see that 10 is our longest side here, so that's going to go in for C. So we have 10 squared. Again, we're going to stick with the box because we don't know if it's greater than, less than, or equal to. And then we have our 2 side lengths here. And then our remaining 2 sides are going to be our A and our B. Again, it does not matter which one goes in for A and which one goes in for B. So I'm going to pick 6 to go in for A and 8 to go in for B. Now 6 times 6, or 6 squared, gives us 36. 8 times 8, or 8 squared, gives us 64. And 10 times 10, or 10 squared, gives us 100. 36 plus 64 gives us 100, and 100 is equal to 100. So according to our rule here, this is a right triangle. All right, now we're going to move on to special triangles here. All right, so we had 2 kinds of special triangles. We had a 45, 45, 90 triangle and a 30, 60, 90 triangle. Okay, we're going to go over the ratios for both of these. Remember that our special triangles are to help us so that we don't have to use the Pythagorean theorem every single time. They're supposed to help us find 2 sides at a time using these ratios. All right, so first let's do the 45, 45, 90. Remember that for the 45, 45, 90 triangles, the 2 legs are going to be equal. I'm going to pick them to be 1. So no matter what they are, whether they're 1, 7, 513, they will always be equal. Okay, and then whatever the legs are, the hypotenuse is the leg length times the square root of 2. I remember that it's the square root of 2 by thinking that we have two common angles here. The 45s match, okay? Now for the 30, 60, 90 triangle, this one's a little more complicated. We have the short leg, the long leg, and the hypotenuse. So we have three unique parts here instead of just two legs. All right, so our short leg, I'm going to pick that to be 1. To go from our short leg to our hypotenuse, we have to multiply by 2. And remember, if we were going backwards, hypotenuse to short leg, we would divide by 2. And then short leg to long leg, we would take our leg length times root 3. And remember, if we were going backwards, long leg to short leg, we would divide by the square root of 3. I remember that it's the square root of 3 here because we have three unique angles, 30, 60, 90, no repeats. So let's go ahead and do these problems here. So number 3, we have a 45, 45, 90 triangle. We have the sides B, A, and 2 root 2. So as we can see, one of our legs is 2 root 2. So we know that the other leg has to be identical, it has to be congruent, has to be equal. So that B, that our other leg, has to be 2 root 2 as well. Now our A is a little bit more complicated. If we look back up at our reference picture, to get from our legs to our hypotenuse, we take our leg length and we multiply by root 2. So we're going to do that here as well. Take our leg length of 2 root 2 times root 2. All right, so the first thing we're going to do, just like we did in 9.1a, we're going to multiply our coefficients. So we have 2 times our unwritten 1 is going to give us 2. And then root 2 times root 2 gives us root 2 squared. And remember that the square root and the square cancel out, leaving us with just that 2. And 2 times 2 is 4. So our hypotenuse is 4 here. All right, and then for number 4, our last one, we have a 30, 60, 90 triangle here, where we have 30, 60, our side lengths of 5 root 3, y, and x. All right, so we start with our long leg. If we look back up to our reference picture, we can see that the long leg is whatever the short leg is times root 3. So if we look at the number in front of our root 3, or we divide out by that root 3, we can see that that y, or our short leg, is just the number in front, just that coefficient. It is 5. And then looking back up to our reference photo again, going from our short leg to our hypotenuse, we have to multiply by 2. So to get from our short leg to our long leg, we multiply this 5 by 2, getting 10.